2 asks a lot of the same questions, except now we have the graphing calculator to help us out. Right? So our velocity is given as this rational expression, and for t greater than or equal to 0, when is the particle moving to the right? That means when is the velocity greater than 0? So let's go to our calculator, and there's our velocity. We want to know when that function is positive. Right? And we are given the idea that t is greater than or equal to 0. So we're going to punch in for our window an x-min of 0, and well, I don't really know what we want for an x-max at the moment. Well, let's just put in 10, and our y-min can be negative 10, and our y-max can be 10, and let's see what we get for our graph. Okay, so we actually need to, all right, we see here that the graph is, it does increase and goes over into the positive area, and then negative again. If I zoom in a little bit with my y-axis, I'm going to go back to my window, and I'm going to make my y-min negative 2, and my y-max 2, and let's see if this makes things a little bit better. Yeah, so there we go. So now we're positive, and then our function turns negative, and it continues to decrease. So it's only in this region right here where the velocity function is positive. So let's find out what those regions are. The first one happens between 0 and 1. So I'm going to do a 0 finder, so second trace, 0 finder, and my left bound is 0 and my right bound is 1, and I'm going to guess looks like 0.4. So it turns out it's actually 0.2679. All right. So the particle is moving to the right, beginning at 0.2679. And when does it stop moving to the right? Well, it stops moving to the right once the velocity becomes negative, which is somewhere between 1, 2, 3, and 4. So let's do a 0 finder again. All right. We're going to, left bound is 3, right bound is 4, 4.5 is right there in the middle. Oops, what did I do? No, that's the 3.5 is right in the middle. Let's try that again. Second trace, 0 finder, 3, 4, 3.5. When you put a guess that's not in between, it doesn't like you. So there we see there that's 3.732. Right, so 3.732, and on that interval, the particle is moving to the right because the velocity is positive. Part B, write and evaluate an integral expression that gives the total distance. All right, so we know we're looking at the integral. Our bounds are 0 and 6. And we want the absolute value of our velocity function. Okay, now bringing the calculator back, the velocity function is right there in y1. So we go to the main screen, and we're going to do math 9. Right, and our low bound is 0, and our upper bound is 6. And we need absolute value, which can be achieved one of two ways. If you have the new operating system, you do alpha window, and it's right there as option number 1. Let me quit out of there. If you don't have the new operating system, or if you just want to do it the old-fashioned way, you're going to hit the math button, and then go over to the number menu, and you'll see it right there as option number 1. That's there no matter what the operating system. So we hit enter, and we have the absolute value, and our y1 is going to go in there. So alpha trace y1, and then dx, and it's going to think for a little bit because of the complicated function and the fact that we're taking the absolute value of that function, and eventually it is going to pop out our answer. Now while it's thinking, let's go on to the next one, which is to find the total distance from 0 to 4. So it's more of the same thing, 0 to 4, and absolute value v of t dt. All right, our first answer is back. We see we have 2.3856. 2.3856. And now it's time to do this one. So we bring the calculator back. I'm going to push up so I can get to my old one and hit enter. So it copies me down. And all I'm going to do here is change the 6 to a 4. And doing so, again, it's going to think for a little bit. And while it's thinking, we're going to actually go to part D. Is the speed of the particle increasing or decreasing at time t equals 2? So we know that we have to do v of 2 and a of 2 in order to find out if we have the same sign or different signs. All right, our answer is back. So we can see here that our answer to part C is 1.94103. And now it's time to get the velocity function at 2. So in order to do that, since our velocity function is in y1, we do alpha trace y1, and we do immediately in parentheses the 2. This does not mean the function times 2, it means what's the function evaluated at 2. Again, y1 is our velocity function, so we hit enter and we see we get 3 over 5. And that's actually not all that hard to get. We could have gotten that if we went up here and just plugged in 2 in the top and the bottom. Okay. We also have to plug 2 into the derivative, but we don't have the derivative. But the cool thing is we can use the graphing calculator to get the value of the derivative at a point. All right, acceleration is the derivative of velocity, so we're going to do math 8 to pull up our derivative function. d dx, we're going to take the derivative of y1, so alpha trace, and we're going to put in the y1. We're interested in the derivative of our velocity function when x is 2. So enter in a 2 there and hit enter, and there it is, negative 0.4799. All right, so we have a of 2 is negative 0.479. Repeating, I think that's actually going to be negative 4.8, but that's okay. We're not going to, we could round that if, no, we cannot round, yeah, we could actually round that and it would be okay, but let's just go that accuracy right there. One is positive, the other is negative, so speed is decreasing. And the reason why speed is decreasing is because v of 2 is positive and a of 2 is negative. All right, last but not least, we want to find the position of the particle at t equals 3. So the position at time t equals 3 is equal to the position at time t equals 0. And way back up here, once again, we see that time 0, the position is 3. We're going to have 3 plus the integral, the position is 3 when t is 0. We're interested in when t is 3, these numbers should always match, right, of our velocity function. And this time there is no absolute value because when we're talking about change in position, we want to take into account when the object is moving backwards or to the left. So we go back to the calculator one final time and we're going to do 3 plus math 9. And we have 0 and 3 as our bounds, and y1 is our function. dx, hopefully this won't take too long. It does not. And we see there 4.605. That is the position of the function when t is equal to 3.